Hello students, welcome back to my channel. So we are learning the chapter 10th, which is inheritance. Today's session is the third session of the same where we will be completing this chapter. In session we will discuss virtual base class, abstract classes, as well as constructors and destructors, how we are going to use them when it comes to inheritance, right? So let us begin with virtual base classes. So what do you understand by virtual base classes? We all know that what is a base class. Base class is nothing but a class which is going to allow its property to be inherited to another derived class, isn't it? So what do you mean by virtual base class? So let us see the definition. When two or more objects are derived from a common base class, we can prevent multiple copies of base class being present in an object derived from those objects by declaring the base class as virtual. So when we declare a base class as virtual, that is when it is called as virtual base class. So what is the meaning of that? For example, I have a base class, okay? I am deriving, two classes are deriving its property. Now suppose I am having another derived class, okay? And this is deriving their this first derived class and second derived class. So what is going to happen? Suppose I have some object here which is being derived by this one as well as derived by this one, and also the same properties has been derived by here, the same derived class. So what is going to happen? There is going to be a duplication in this particular class, isn't it? Because both of them have derived the same property from base class, as well as this derived class is going to be deriving it from both of them. So there is going to be a duplication. So that is what we are talking about. So to prevent multiple copies of the base class being present in an object, what we will do, we will declare this base class as a virtual base class. So when we do that, we will avoid such duplication. So such base class is known as virtual base class. So where we are going to declare the base class as virtual, we are going to call that base class as a virtual base class. And how do we do that? We use the keyword virtual. Okay. So whenever we are declaring a base class, we are going to use the keyword virtual, and then we are going to go ahead and do the code. Then there is not going to be any duplication when it comes to the object of the derived class, right? Let us see one example here. So see here, I have a base class A. So I have a base class A, derive class B. So this is a class B which is deriving, get one copy of the base class. So what happens? The data, whatever is there, we have one copy here. I have derived class C. Again, one more copy of this is over here. Now, same example. I am deriving another class D. Okay, what type of a inheritance this is? Only this if I'm taking. This is multiple inheritance, isn't it? I'm taking from two base classes. I'm deriving a one base derived class. From two base class, I'm deriving one derived class. This is multiple inheritance. So what is going to happen? Whatever the content was here from the base class, the same content is here from the base class. Now again, I'm creating two copies of the base data here. So that is what is happening. This is what the problem when it comes to inheritance. Okay. So that we are avoiding using the virtual base class method. So how am I going to declare it? So see the example here. So I'm going to use the keyword virtual. So where I'm using, this is my base class. Okay. So this is my base class. My base class is here. Class B virtual public key. We know the syntax to declare a inheritance, isn't it? So in the derived class, how am I going to say? I'm going to say class keyword, name of the derived class, colon, the visibility mode, and then the name of the base class. So here I'm adding another keyword called as virtual so that there is no duplication. Okay, so what is going to happen? Class B is deriving it here. Next again, class C is deriving from A. Okay, so class C is deriving from A, and then class D is deriving from public B, comma public C. Means I am deriving another class D from B and C. So now that I have declared the base class as virtual, there won't be any duplication when it comes to the derived class, right? I hope this is clear. So that is what the meaning of the virtual base class is, right? Next, let us move on to abstract classes. So what is this abstract classes? An abstract class is the one that is not used to create objects. Now, which one is the abstract class when it comes to inheritance? So usually the definition of abstract class is the one which is not used to create objects. We know that as soon as we have a class, whenever I declare a class with some properties, the main goal is I'm going to create an object of this class and I'm going to use it, isn't it? For example, I will say A, which is nothing but I'm creating an object of class A. And that is how I'm going to access these properties. Now, whenever I'm not creating any object, not used to create any object, such classes are called as abstract class. So what are these classes? Which type of a classes we do not use to create objects? Now see here, an abstract class is designed only to act as a base class. So what is going to happen? A base class is usually the one whose objects we do not create. Why do we not create? Because we already have so many derived classes which are using its property, and we create the objects of those derived classes. Hence, we do not need to create any object for the base classes. That's why usually the base classes becomes the abstract classes. So two things to remember here. What is an abstract class? It is nothing but a class whose objects we do not create, and usually they are the base class. Okay, usually the abstract classes are the base class. Okay, moving on to the last topic of the day, that is constructors in derived classes. So we all know what is a constructor. What is a constructor? Constructor is nothing but a function whose name is same as that of a class, and they are usually used to build the object, as in to initialize the object, isn't it? Now if at all I'm using it in the inheritance concept, how am I going to do that? So see here, as long as the base class constructor takes any argument, the derived class need not have a constructor function. That is, suppose I have a base class. Okay, I have a base class where I have a constructor. Right, so when we invoke a constructor, whenever we create an object, suppose the constructor is taking an argument, only then my derived class need to have the constructor, otherwise it is not necessary to have. Why it is necessary for a derived class to have a constructor? Because we are going to mainly create the objects using the derived class, isn't it? Like just now we have learned, usually it's not in all the cases, but base classes are usually abstract classes, the ones whose objects we do not create. If we are not creating an object, we will not be able to call the constructor itself. Hence, if at all a base class has a constructor and it takes any argument, if at all we do not have such constructor, then even destructor need not have a constructor with a constructor function. But if at all a base class has a constructor with parameters, and it's a duty of the destructor also to have the constructor, right? If any base class contains a constructor with one or more argument, then it is mandatory for the derived class to have a constructor and pass the argument to the base class constructor. So that is what we are talking about. If at all a base class has a constructor, we should make sure that the derived class also has a constructor. Why? Because when I'm creating in the main, when I'm creating the object, where do we call the object? We call the destructor, isn't it? So we do not call the base class directly. So when I'm invoking the destructor, it is my duty to invoke the base class constructor. Hence I'm supposed to have the constructor in the um, derived class as well. That is the reason, right? So that is what the meaning of these statements are. So when do we do that? While applying inheritance, we usually create objects using the derived class. That is what I said. When applying inheritance, we usually create the object for derived class and not for the base class, because base class is abstract class. The base constructor is executed first and then the constructor in the derived class is executed. Okay, of course, because as soon as we call the object, what happens? Once again, I have my object here. What happens? Through the derived class, I'm going to be calling the base first. That is the base, destructor, or the constructor. Sorry, the constructor gets called first. That is how I'm going to initialize my value. So once these values are initialized, and then the derived class constructor gets initialized, right? Because of course the base class is main. From there the data flows to the derived class. So when the object is called, the base class values gets initialized first. So that is what the meaning of this statement. In case of multiple inheritance, the base classes are constructed in the order in which they appear in the declaration of the derived classes. Similarly, in a multi-level inheritance, the constructor will be executed in the order of inheritance. So that is what in multi-level and multiple. So depending on what kind of inheritance we are using, depending on that, the value of the constructor, that is nothing but the initialization, happens. Okay. So this is about constructor. So it becomes little complicated when it comes to constructor, but once you understand how the data always flow from the base to the derived class. When it comes to constructor, it becomes more clear. Next is destructor. How does a destructor work? Destructor, we know that um, it works in a opposite. That is, if the constructors are called down the line from the base, that is usually constructor, what did we say? It from the base to the derived class, isn't it? Usually when I'm initializing, it always first initialized in the base and then it moves to the derived class, wherein which destructor happens in the other way. That is, the whatever the destructor is here in the derived class gets called first, executed first, and then in turn it calls the base class destructor and then it gets executed. Okay, so this is the form, derived class up to the base class. So when it comes to the constructor, how do we work? We work from base class to the derived class. When it comes to the destructor, what do? We work from, if this is my base class, derived class, we go up to the base class. From the derived class, we go up to the base class. I hope this is clear. These are very small concept which you need to know. Okay, so that is the last part of this particular chapter. I hope these videos are helping you all in your studies, right? With this we have ended this particular chapter. Thank you for watching, students. Keep learning.